Okay, let's see question 11. Shannon was born on February 02, February 22nd, 1982. The question is asking how many 8-digit codes could she make using the digits in her birthday? So the digits in her birthday, we have 0, we have 1, we have 4 twos, 2, 2, 2, 2. Then 8, then 9, right? So 8 digits in her birthday. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 digits code. So this is a code. So let's think. So how many choice? So there are 2 ways of doing this. So I'm going to show one way first, then do another way, because there's no condition over this. So one way is just to think, okay, I'm going to just draw digits from this. So for the first place, how many I have? I have 8 choices, right? I can use 0, I can use 1, I can use these 2, this 2, this 2, this 2, or 8 or 9. So I put A here. So once I choose 1, put here. So non-repeating. So this one is non-repeats. Repeats. So non-repeats. So I choose one, any one of this A to be here, to be in the first place. I only have 7 left. So then next I have 6 left, I have 5 left, I have 4 left, I have 3 left, I have 2 left, then the last one. So by counting principle, I multiply them. So I multiply the choices. So what is this? This is just A factorial, right? But then we have to consider, I have 4 twos, right? The twos are the same. So basically in this permutation, I have permuted these 4 twos. So that's, so 1, 2, 3, 4. If I choose the first 2, right? I have choose the first 2, I have 4 of them. Second one, 3 of them, 3 choices, 2 choices, 1 choice, right? So that means I have permuted these 4 twos this many times, which is a 4 factorial. So what do I have to do? I have to divide. Right? I have to divide A factorial with a 4 factorial. That's how many unique codes I can make. So A factorial I can write as A times 7 times 6 times 5 times 4 factorial, then divided by 4 factorial. Right, 4 factorial divided by 4 factorial, that's 1. So I just have to multiply these 4 numbers. So 5 times 6, 30. 7 times 8, 56. So 56 times 30, what do I get? The 0 in the end, 3 times 8, 18. Carry on 1. 3 times 5, 16. 3 times 5, 15, plus this one, 16. So 1,680. So that's the answer here. But some of you may argue with me, right? You didn't say repeat or no repeat. So if it can be repeated, right? If it can be repeated, I still have 8 spots for the code. 1, 2, 3, 4, 5, 6, 7, 8. So how many unique digits I have? I have 0, I have 1, I have 2, I have 8, I have 9, right? So the first one, so 1, 2, 3, 4, 5, I have 5 choices. Second one, I have 5 choices. You know, each spot, I have 5 choices. So that means by counting principle again, I can multiply by this. So I get a 5 raised by 8. Well, 5 raised by 8 will be a much larger number than 1,680. So let's do that. So 5 raised by 8, I can simplify. I don't want to, press in 5 like 8 times. So what I could do is I could think of 5 square, then raised by 4, right? because 5 squared is 25. 25 raised by 4. So I just do 25 times 25 4 times. But if I have exponents, I could just do 25 raised by 4. So the calculator tells me there's a 390,625. Okay. So either way, you show, one of those answers, either way, I'll treat them as right because the question didn't specify if repeats allowed or not allowed. Okay, that's for question 11.